the record button. And now I'm going to share. That way I don't have to do a separate video like I had been doing. And they will probably get uploaded in a more timely manner. Okay, so an inscribed angle. Notice where the vertex is. The vertex is on the circle. Okay, so an inscribed angle, the vertex is on the circle instead of at the center. Okay, so even if, even if they only drew this part of the angle, since the vertex is on the circle, you can extend these sides to figure out what the intercepted arc is. And the intercepted arc is where the angle cuts off the circle. So this right here is the intercepted arc. With a central angle where the vertex is at the center, the measure of the arc is the same as the measure of the angle. But if you're talking about an inscribed angle like this, let me make sure. Okay. So the measure of an inscribed angle is 1/2 the measure of the intercepted arc. For example, if this arc right here measured 60 degrees, then this angle would measure 30 degrees. The angle is the measure of an inscribed angle is 1/2 the measure of the intercepted arc. And so if you know the angle, you double it to get the arc. You know the arc, you 1/2 it to get the angle. If you have two inscribed angles that intercept the exact same arc, then those two angles are congruent. And that should make sense because they're both 1/2 of this arc. So you can't do 1/2 of the same arc and get two different answers. If an inscribed angle intercepts a semicircle, then that inscribed angle is a right angle. Because a semicircle is 180, 1/2 of that would be 90. What is also true is inscribed angles let's say this, the opposite angles in an inscribed quadrilateral are supplementary. Remember, that means they add to 180. Okay, so if we look at angle B and angle D, just in theory, okay, so if we're talking about the measure of angle B and D, let's pretend that this arc here measures, let's say, what's going to be like 100. Okay, that arc measures 100. Okay, which would mean this arc would be the rest of that 360 degrees, which that other arc would measure 260 degrees. So angle B intercepts this 260 degree arc. So angle B would be 130 degrees. Angle D intercepts this 100 degree arc, so it would measure 50 degrees. And you can see that those are supplementary. Those add up to be 180 degrees. So if you have an inscribed quadrilateral, the opposite angles are going to be supplementary. Okay. So let's look at, I am going to work through these examples because you have another page to do. All right, so example number 1 says find the measure of angle P. So if we look, angle P is an inscribed angle, so we have to find its intercepted arc, which is MQ. So I'm going to write this out. The measure of angle P is 1/2 the measure of arc MQ. So the measure of angle P is 1/2 of 70, which means the measure of angle P is 35 degrees. And then B says find the measure of arc PN. Okay, so if the angle is half the arc, that means the arc is twice as much as the angle. So the measure of arc PN is twice the measure of angle Q. So the measure of arc PN is 2 times 56. And you guys know you don't have to show all that work as long as you can get it right. 2 times 156, 2 times 56 is 112 degrees. Any question about example 1? Okay. All right, so number 2A says if the measure of angle T is 3x minus 5 and the measure of angle U is 2x plus 15, find the measure of angle T. So what we know is angle T intercepts this arc SV. Well, so does angle U. If two inscribed angles intercept the same arc, that means they're congruent, which means the measure of angle T equals the measure of angle U. So I can set up this equation. Measure of angle T is 3x minus 5. Measure of angle U is 2x plus 15. Solve that equation, subtract 2x from both sides, and you get x minus 5 equals 15. Add 5 to both sides, so x is 20. So to find the measure of angle T, so you take that 20 and you plug it in right there. Measure of angle T is 3 times 20 minus 5. So the measure of angle T is 55 degrees. If you accidentally plugged it in right here, the good news is those two angles are congruent, so you'd still get 55. So you can see 2 times 20 is 40 plus 15 is 55. Now, if you accidentally plugged it in there and you got something different, then you set the equation up wrong or you solved the equation wrong. Anybody have a question about 2A? Okay, so B says the measure of angle S is 3x and the measure of angle V is x plus 16. Both of those angles also intercept arc TU, so angle S and angle V are congruent to each other, so we can set it up the same way. 3x equals x plus 16. Subtract x, so you get 2x equals 16. Divide, which means x is 8. And you can plug it into either S or V because they're congruent. So the measure of angle S is 3 times 8, which is 24 degrees. Okay. Any question about number 2? Okay, number 3. Okay, I don't have any angles marked, but I do know that FH is a diameter because it's a chord. It has endpoints on the circle and it goes through the center. So FH is a diameter. Remember that, so this is a semicircle. This arc is a semicircle, and any inscribed angle that intercepts a semicircle is a right angle. So that means G is a right angle. So it says measure of angle F is 7x plus 2, and the measure of angle H is 17x minus 8. Find x. Okay. So I don't know about arc FG or arc GH, so I can't say those are equal or one's half the other or anything like that. But I do know that the 3 angles of a triangle add up to be 180, and 90 is already taken up with angle G. So I know that the measure of angle F plus the measure of angle H equals 90 degrees. So 7x plus 2 plus 17x minus 8 equals 180. Nope, sorry, 90. 7 plus 17 is 24, so 24x minus 6 equals 90. Add 6, so 24x equals 96. Divide by 24, so x is, x is 4. Anybody have a question about number 3? All right, so number 4, you got to make sure and read what it says to find. It says to find the measure of angle A and the measure of angle B. It doesn't say to find the measure of angle D, but notice that D is just x. So in order to find the measure of angle B, we got to know what x is. So we have to find the measure of angle D. Now, we don't have to do any real calculation to find out the measure of angle A, because remember, if a quadrilateral is inscribed, then opposite angles are supplementary. And since angle C is 90 degrees, that means the measure of angle A is also 90 degrees automatically, so we don't have to do any work for that. But we do need to find out what the measure of angle B is. So, like I said, I know that angle B and angle D, since they are opposite angles in an inscribed quadrilateral, that they are supplementary, meaning they add up to be 180. So 2x minus 30 plus x equals 180. 2x plus x, that's 3x minus 30 equals 180. Add 30, so 3x equals 210. Divide by 3, so x is 70. Now x is angle D. It didn't say find angle D. We've got to plug in that 70 up here to figure out what angle B is, or we can just subtract from 180 because we know angle B and angle D are supplementary. So 180 minus 70 is 110 degrees. So the measure of angle B is 110. Now, on the notes, I didn't use that common sense there, and I plugged it in. But guess what? I got the same thing. I got 2 times 70 minus 30. That's 140 minus 30, which is still 110. So if whatever way you do it, you'll get the right answer. Just one way might be easier. Anybody have a question about number 4? Is everybody good on that?